In 2021, one of the biggest companies on Earth just disappeared. No Facebook, no Instagram, no WhatsApp for 6 hours. Not because of a hack, not because of a cyber attack, not because of any malicious actor, because of a configuration error. One engineer typed the wrong command. And just like that, a company with 3.5 billion users went offline. The way it happened reveals something uncomfortable about how the internet actually works. Because the internet doesn't have a control room. There's no master system deciding where your data goes. Instead, the internet runs on trust. Networks tell each other where things are, and everyone just believes them. That system is called BGP. And if one network lies or makes a mistake, parts of the internet don't slow down, they disappear. You open your laptop, type in a website, hit enter, and within milliseconds, your request travels across cities, countries, entire continents, before coming back with a web page. It feels instant, effortless, almost simple. But underneath that simplicity is one of the most complex systems ever built. Because your data doesn't just travel as one piece. It's broken down into tiny chunks called packets. Each one carrying where's it going, where's it come from, just enough information to figure out the next step. And every step of the way, something decides where does it go next. That something is a router, or for our American friends, router. Think of it like a global postal system. Packages arrive, labels get read, they're sent to the next destination. Routers do this millions of times per second. But here's where things change. The internet isn't one network. It's thousands and thousands of separate networks, independent, privately owned, sometimes competing. ISPs, cloud providers, universities, governments. Each one runs its own infrastructure. Each one makes its own decisions. These are called autonomous systems, and every time your data moves across the internet, it's hopping between them. Which raises an obvious question. How do all these independent networks agree on where anything is? Inside a single network, things are controlled, predictable. Engineers design the layout. Routers share maps. Paths are calculated. Protocols like OSPF, Open Shortest Path First, handle this beautifully. They find the shortest path, adapt quickly, stay efficient, everything is ordered. But the moment your traffic leaves your network, you enter a completely different world. Now you're moving between organizations, different owners, different priorities, different incentives. And there's only one protocol that handles this. BGP, Border Gateway Protocol. It's often called the protocol that holds the internet together. Every website, every video, every request, BGP decided the path. But here's the strange part. It doesn't try to find the fastest route. It doesn't even try to find the most efficient one. It finds the path that networks agree to use. And that agreement is based on policy, business relationships, and trust. Here's how it works. Two networks connect. They establish a session. They start exchanging information. Network A says, I can reach these addresses. Network B says, here's how to get there. That information spreads from network to network, hop to hop, until the internet builds a kind of shared understanding of where everything is. Not because there's a master map, but because everyone shared what they believe. And here's the key detail that matters. When a network announces a route, others usually accept it. No global verification, no central authority, just trust. And this works because historically, networks haven't had a reason to lie. They follow rules. They maintain relationships with their upstream providers. There's structure built on reputation. But the system has a weakness. What happens when something false gets announced? In 2008, Pakistan's government ordered ISPs to block YouTube locally. Pakistan Telecom announced to its upstream provider, "I know where YouTube is, send that traffic to me." That announcement was more specific than YouTube's real route. In BGP, more specific routes get priority. So routers around the world believed it. The announcement spread. Within 45 seconds, central routers on which most internet traffic relies started sending YouTube traffic to Pakistan. YouTube disappeared from the global internet. Not because of an attack, because the system worked exactly as designed. Then, in October 2021, Facebook made a configuration change during routine maintenance. An engineer issued a command to assess backbone capacity. But that command had a bug. It accidentally disconnected all of Facebook's data centers from each other. Normally, Facebook's DNS servers would immediately withdraw their BGP route announcements if they couldn't reach the data centers, a safety mechanism. And that's exactly what happened. Other networks believed it, accepted it, propagated it. And just like that, Facebook, Instagram, WhatsApp, and Messenger stopped existing on the internet for 6 hours, with 3.5 billion users trying to reconnect simultaneously. The outage cost Facebook at least $60 million in advertising revenue. Mark Zuckerberg's wealth fell by more than $6 billion in a single day. It happened because one engineer typed the wrong command. But here's what matters the most. The internet didn't fail technically. It failed because the system worked as designed. When multiple paths exist, BGP chooses based on attributes: local preference, path length, origin MED, multi-exit discriminator. But those are just mechanics. The real driver is policy. Networks have relationships, customers pay providers, peers exchange traffic, competitors avoid helping each other. So routing becomes an economic decision. Send traffic this way, it's cheaper. Avoid that route, no agreement. Prefer this path, we get paid. Which means something uncomfortable. The path your data takes isn't just technical, it's economic, sometimes even political. And once you see that, you can't unsee it. If this interests you, and if you want to understand how the internet actually works, where the vulnerabilities are hidden, how systems that feel reliable can just catastrophically fail, this is the channel. Hit subscribe. We break down these infrastructure stories regularly. The assumptions that power everything, the ways those assumptions fail. And seriously, drop a comment. What surprised you most about how BGP actually works? Because I think most people have no idea that routing is policy driven, not just a technical decision. Back to the story. The uncomfortable truth is this. The internet runs on layers of trust. BGP trusts that networks announce their real routes. But there's no cryptographic verification, no central authority checking, just agreements between neighbours. And if a neighbour breaks that agreement, whether intentionally or accidental, the whole system accepts it. This isn't a bug, it's a fundamental design choice. BGP was built for a smaller internet, an internet where the major players knew each other, where relationships meant something, where everyone had a vested interest in keeping things stable. And for decades, that worked. But the internet has grown beyond that. We have tens of thousands of networks now, not all of them trustworthy, not all of them careful. And BGP still operates on the same principle. If you announce it, we believe it. There are solutions. RPKI, Resource Public Key Infrastructure, would cryptographically verify root origins, but adoption is slow. Most networks still don't use it, which means the core vulnerability remains. A misconfiguration, a malicious actor, a government order. Any of these can petition the internet. The genius of BGP is its simplicity. Networks don't need central coordination. They don't need permission from anyone. They just announce what they know. And the system converges. It's elegant. It's scalable. It works. Until it doesn't. And when it breaks, there's no failsafe, no backup protocol, no override system. Just routers that were built to trust, suddenly realizing the trust was broken. And by then, you're already gone. Off the internet, unreachable, waiting for engineers to physically access routers and fix the misconfiguration. The internet feels solid, but it's held together by systems that assume everyone's being honest. And that assumption is getting more fragile every day.